Okay, welcome back to this beginner's course on Excel eSports. I've covered the fundamentals section and we're now in the specific game types, starting off with data games, which covers most of them. We've done a text video. This video is going to be all about numbers. There's more to come in this course. We'll go through all of this on screen, so subscribe if you would like to follow along. So I noticed that a lot of my viewers are actually on mobile, so I'm going to zoom in for this one, so hopefully you can see things a bit clearer. So the first thing you'll need to be able to do with numbers is tell if something actually is a number. So there's a formula for that, just called isNumber. So if I highlight this, you'll see it's not a number because it has all these dashes in it. The next crucial thing to know is that when you use text formulas on anything that has numbers in it, so let's text split this down. So text split this with the dash, that will pull out all of the numbers. So now let's just do our test again. isNumber, these things, we can see that they're all false. These are not numbers, they are text. So if you were to do something like sum these things, it would come to 0. However, what's quite strange is if you plus them manually, so if you plus them all like this, you will actually get the right result. So when you use the plus, Excel will kind of know what you're trying to do and make it work. But when you wrap it inside a formula, it won't. So how do you correct that? Well, the first thing is that whenever you use a text formula, left, right, mid, text before, text after, text split, you need to always remember that it's going to come out as text. So the easiest way to convert is to times these things by 1. And now they are numbers. So an easy way to tell is that text is generally aligned to the left and numbers are aligned to the right. So that's another little tip to be able to tell if something is formatted as a number or a text. So now, if we choose to sum all of those things in our array, we will get the right answer. Sometimes you'll want to go the opposite way. So right now we have these formatted as numbers by multiplying by 1 to force them into numbers after doing our text split formula. And let's say we want to do a VLOOKUP or XLOOKUP, we'll do VLOOKUP this number in here, give me column 2, and we get NA, it's not there. We get this little triangle to tell us it's not a number, so we could convert it to a number like that. However, it's often easier to convert what we're looking up and not change our base data if this was base data in a case. So a better way would be to do ampersand blank. So that is a very quick way to force things to become text. So if I say equals these, ampersand, double quotation marks, that's going to convert them into text by kind of adding a blank character onto the end. So that's how to convert between numbers and texts. Now the next topic is looping and reversing. So it doesn't always have to be numbers, but normally is. Let's say we want to cycle something over and over again. So let's say we wanted to repeat this sequence over and over again, or determine if this was a game board or something, where we would be after 20 steps down if after 7 we loop back to 1. So for this, you're just going to use the mod formula. We're going to take our number and our divisor, in this case, is going to be 7. So the divisor is basically the maximum of your number. So when we get to 7, it becomes 0. If I say 8, 9, and so on, we see that we repeat 1 to 6, 0, 1, 2, and this would go on and on. However, we want the 7 to actually come out as a 7. So to fix that within the mod formula, we do a -1 inside and then a +1 outside. And now instead of 0, we'll get a 7, and 8 will become 1, and so on and so on. So a question like where would we be after 20 steps, we would say equals mod. Our number is 20 steps. We're going to do a -1 inside. Our divisor is 7, and we're going to do +1 outside. So that tells us we would be on number 6 here. And just to prove that out, let's actually add 20 steps to this. So let's do sequence of 20. Spill our little mod trick down, and you'll see that we land on number 6. So we're cycling up to a max of 7. Now let's talk about reversing sequences. So say we wanted to reverse this. Well, what we would do is we would say index this on sequence of 7. So that's going to give us everything in this list in positions 1 to 7. But we want to reverse the sequence, so we want to go from position 7 to 1. So we change our sequence to start at 7 and go in steps of -1. So that will reverse that just like so. And this will also work with letters as well. So if I said A, B, C, D, E, F, and we have a G there as well, you'll see that we reverse the letters. So to show you what we're doing, we're saying sequence 7, start at 7, go in steps of -1. We're taking a reverse ordered sequence, and then with index we're saying pull out everything from this list in these positions. So it pulls out position 7 first, then 6, then 5, then 4, and so on. And the good thing about sequence is you can pull things out in steps of 2, so you could pull every other item out of this list, items in reverse order, every 2 items in reverse order, anything else you like. So sequence is a very powerful formula. If you watched the text video earlier in the week, the stuff in that video combined with this will also teach you how to reverse text strings. So you could break a text string down into its component letters, which is what we covered last time, reverse it, and then concatenate it back together, and you have the text in reverse. Next, let's talk about different bases. So this comes up quite often. So obviously we work in base 10. We go from symbols 1 to 9, and then when we get to 10, we start a new column of digits, and then we go 1 to 9 again, and then we up the digit on the left. So that's base 10, and we probably work in that because we have 10 fingers. But if you wanted to work in base 5, you would have symbols 1, 2, 3, 4, and then 1, 0, what we see as 10, would actually represent a quantity of 5 of something. So there's a few ways to convert bases. So you can use dec to something, so dec to bin is dec to binary. So I could do that, and it will change all of these to binary. So this is the binary format of these numbers. There's also stuff like dec to hex, and so on and so on. However, the thing I don't like about these formulas is that they don't work on arrays. So if I was to do this on the whole array, you'll see that we just error out. So what I much prefer is the base formula. So if I say base of these numbers, my radix, we could say 2, for example, to go to binary, and we'll get all the digits there. It works on arrays, and I think that's just a nicer way to do it. And you also have an option here to have minimum length. So if I said the minimum length is 5, then actually we're going to get everything of the same length, which can be nicer to work with. If we want to do the reverse, we have the decimal formula. So decimal of all of this stuff, again, works on arrays, and our radix, i.e. the base we put it to, was 2, so that will convert back to decimals. With this base formula, we can actually go all the way up to base 36, so that's 10 digits, 0 to 9, and 26 letters of the alphabet, which makes 36, so we could go anywhere from, up to base 36. So if we just do base 30, you'll see we get 1, 2, 3, 4, up to 9, and then we'll go through the alphabet, like so. And right now this decimal isn't working because I haven't told it we're in base 30, now it knows, so we can convert back. Hexadecimal has been used quite a lot, which is base 16. So that's letters up to F, with 1 0 representing a quantity of 16 of something. Next up, a little trick. So sometimes we need to kind of clamp a number between a lower bound and an upper bound. So let's say these were all representing a percentage that couldn't go below 0 or above 1. So an intuitive and acceptable way to do this is to say max of that number and 0. That means we'll never go below 0, and then wrap it in minimum of that and 1, which means we'll never go above 1. So that will pull, kind of put our numbers into bounds. So there's actually only 2 numbers that fall within our range. If we change that to 0.6, for example, we see 0.6 falls out. That's within our acceptable range. However, this notation's a little confusing. A more unintuitive way, but simpler to write, is to say equals median of 1, 0, and your number. And you'll see that we get the same result. Now this is because median is ordering the numbers. So if a number ever goes above 1, it would mean that 1 is in the middle of these 3 digits when ordered, and 0 would be in the middle if we were ever below 1. Otherwise, this number would be in the middle. So the median puts numbers in order and then takes the middle one. So that's a very nice, quick way to cap things between 2 bounds. Okay, now we're going to get a bit more technical, but this is a numbers video, so it's always going to kind of go that way. So a lot of times recently we've been asked to do calculations on big numbers. So let's say we had this calculation, 44 to the power of 15. Well, if you do that in Excel, so we take 44 and we keep timesing it by itself over and over and over 15 times, what you'll see is Excel starts to remove the digits at the end and just put a load of zeros there. Now there's been a few questions that kind of stemmed from the simple case by Michael Jarman, which was all about this kind of limitation in Excel. So how do you solve this problem? Now, the way a lot of people have gotten around this is to write lambdas, but I'm going to show you how to do it without lambdas. So a lot of the questions will ask for the last 5 digits. And obviously, when we get to the end here, we don't have those. So if you think about it mathematically, let's take this number here that has 5 digits. If we multiply that by 44, we get this number. If we were to multiply this number by 44 again, these first 2 numbers don't really matter because they're in the 700,000s position and the 3 millions position. So when those numbers with a load of zeros behind them get multiplied by 5, it's going to give me something with a load of zeros on it. So the last digits are only really going to be those final 5 digits multiplied by 5. That might not make much sense right now, but let's just show you by doing it. So if I say right of this 5, and remember this is a text formula, and we want to times it by 1 to make sure we get numbers. Then what we can do is say equals that times 44, but we're going to take only the right 5 digits again. and times 1. So what you'll see as we now drag this down, the 5 digits match here, the last 5 digits match here, the last 5 digits match here, and so on. And that will continue down. And we have done a maths trick here to get the actual final digits at the end. So you'll see this one is where we start to get the 2 zeros introduced. So we get 200. Well, the actual final 5 digits are 18176, not 18200. So these are the true final 5 digits. Now, what if we wanted the actual full number with all digits? Well, in that case, I think the easiest way is to use Python because it's not limited in terms of number of digits. So to do that, we type equals py, and then we come into this Python editor here, and we want to do 44, and to do to the power of in Python, it's a double asterisk 15. So Control Enter will give us a Python formula. And what you see is because we're in Excel, we get this whole issue still of the zeros at the end screwing us up. So to get around that in Python, you can wrap the whole thing in string, so that's str. So if I put that in brackets, that's telling me give me the string, i.e. the text version back of that. And now what you'll see is we get the full string, and our final 5 digits, 87424, match 87424. And this is the true number of that calculation, the true output. Now it gets a little more tricky if we were to link this to Excel cells. So let's put our 44, 4 and 15 there. So instead of this 44, we could click this cell, and instead of the 15, we could click this cell. That still works. But if this 44 is text, and you might think, why am I showing you this as text? Because that would not happen in a real case. Well, actually, it does, because if we're asked to add 2 digits here, for example, which was the original idea in the simple case, it was adding digits, these had to be formatted to text to get all of the digits in there. So that is why I'm showing you how to do it if this is formatted as text. So if that is the case in Python, you need to wrap this in integer to turn it from text back to an integer. So if I wrap that in integer, Control Enter to enter a Python thing, we get back to our original source. str for string and int for integer. Use integer to convert the text to numbers and string to convert the numbers back to text to get your final full output. This then allows us an easy way to do addition, subtraction, multiplication, division with really big numbers that you wouldn't otherwise be able to do in Excel. Okay, now some other math tricks. So this is again going to get maybe even more technical, but this stuff does come up from time to time. First up is summing sequences. So if you wanted to sum the first 100 digits, you could say sum of sequence of 100. That would be the intuitive Excel way to do it. However, if these numbers get large and you're doing them within other formulas, it can slow you down a bit, and there has been questions, even very recently, sum the first 10 million digits. Well, there's not 10 million rows in Excel, so you'll actually get an error there and it won't be able to do it. So let's just show you a math trick for summing sequences. It's not necessarily a trick, it's the common way to sum kind of arithmetic sequences in maths. Summing these is 55, so the kind of cheat way to get here is to say equals 10, which is the final digit in our sequence, plus 1 to it, so that's 11, times the numbers together, so we get 10 times 11, and then divide the whole thing by 2. So that gives us 55, which is the sum of the sequence. To visualize why this is true, let's just write the sequence in reverse here. And what you'll notice is if we summed up all of these columns, it will always come to 11. So let's do that. You'll see we just get 11 10 times over because we're reversing it. So this is where the 10 times 11 comes from. We have 10 lots of 11 here, so that's 110, but we need to divide it by 2 because we have this sequence listed twice. So now let's revisit our huge example again. We can say 10 million times 10 million and 1 divided by 2, and we'll get the answer if we convert it back to a number, and that is the answer, and that was a question that came up recently. So that's the trick to doing it, and if you do it this way, the calculation time is much less for Excel rather than constantly summing sequences up. Now if we didn't start at 1, we could start at 4, for example. Then we can list in reverse here. So in this case, of course, they're still going to always sum to the same value on the columns as they would with any sequence here. But instead of doing 10 times 11 and dividing by 2, we need to do the biggest number plus the smallest number to get this 14, and then times that by how many numbers there are in the list. And that is the biggest number minus the smallest number. 10 minus 4 gives you 6, plus 1 gives you 7, so we do 14 times 7 divided by 2. So again, this is quite nerdy maths, but it will actually save your ass a few times in Excel competitions when these questions come up. So now I'm going to talk about logarithms and exponentiation. So this again can be some tricky questions, but if you know the tricks to it, it will save you a lot of time. So consider these questions. What does $100 grow to over 10 years at an 8% interest rate? So I've just listed the equations out here so we can think about kind of rearranging them and how you do these questions formulaically rather than spilling like whole tables in Excel to try and figure them out. So for the first one, $100 at an 8% interest rate is going to be 100 times 1.08. That will give you $108, right? And you do it to the power of how many years you've got, 10 years. So that one's quite easy to do in Excel. So we can do equals 100 times 1.08 to the power of 10. So we get 216. Now what if we had that question the other way around? What was the start value if 10 years at 8% returned 216? So I've put the question marks here where kind of what we're going to figure out in each question, because you can ask about any of them. So this one's quite easy to rearrange it. We're just going to do 216 divided by this stuff. So equals 216 divided by 1.08 to the power of 10. So we get 100. That's correct. So those two are quite easy. So this is where it gets a little tricky. How many years does $100 take to grow to $216 at 8%? So this time we're looking for this question mark bit. And this is where logarithms come in. So for this one, the solution is to say log. Our number is going to be 216 over 100, and our base is going to be 1.08. So that gives us 10 years. So just to clarify that, because it's a very confusing example, but it's come up before in eSports questions. We're basically rearranging the equation to get 1.08 to the power of question mark equals, then it's going to be 216 divided by 100. So we're basically dividing both sides of this equation by 100, so we only have the 1.8 on one side. And then to get to what the power is, you basically do a logarithm to this base of your number. And now the final way around that this can be is, what was the interest rate if $100 grew to $216 over 10 years? So let's rearrange this. We're basically going to do the same thing. So we're going to get 216 over 100. Let's just write it in here, over 100. So that's what happens when we rearrange. And then how do we get the question marks? Well, we need to do the 10th root of both sides. So in Excel, we have square root, but how do you do cube root? There is no like cube root function, and so on and so on. We need the 10th root, so how do you do that? So this is kind of just a basic math rearranging equations thing you kind of need to know if these questions ever come up. To square root something is the same as putting it to the power of 1/2. To cube root something is the same as putting it to the power of 1/3. So we just need to say equals 216 over 100. We'll put that all in brackets so we don't get any kind of BODMAS stuff going on. And that's going to be to the power of 1/10. So if I just put some decimals on that, you'll see that the interest rate was 8%. So with everything being variable here, I've shown you how to get to all of them. Okay, so that's it for this video. There's probably a few things I missed on numbers, but this combined with the text video I released earlier in the week should get you through most data cases. Next time we'll go through dates and then times. They don't come up as often and can catch people out when they do, because there's a few tricky things to watch out for. So I'll see you next time for those videos.